All right, take two. Welcome to this and today I'm gonna be attempting to learn. Well, I don't know anything about kernels. Let's go ahead and start off with that. So kernels are like something that allows you to. Well, let's start with what I know and what I don't know. So basically, what do I know about kernels? Well, there's something that does something with your computer that makes it work. Then the operating system interacts with that, and that tells your hardware what to do. So it's that interface between the hardware and your operating system. So we're gonna try to write our own for a specific board that I have, which is rather unuseful to me. It's an Odroid N2L, which is no longer in production, and not only is it no longer in production, but it is also has no internet, so like there's no way to do much with it. However, I have learned how to kind of do some stuff, and I'm going to pull up Odroid N2L just to show what this even is. It is this shit right here. That's like the internet card too. Like the internet goes in a USB slot, which obviously not really useful to me, but if I can get this to do something interesting, like potentially become a game console, well then this is like the Xbox Plus Plus right here. Xbox Plus Plus, you can put it in your pocket box. Now the problem is that when we're going to develop for this, the thing we're targeting is going to have to be ARM architecture, which it's possible to compile the language we're going to use, which is going to be dlang, since I know dlang pretty well, and I want to get more practice on it, so we should be good to start some complex projects like this, is what I assume, or what I believe, I know for a fact is true, is that we can actually start writing a kernel in it. I think we should start off by asking, like, something that knows more than I do, something that's better at finding information, like some kind of like machine AI. Writing a kernel from scratch is a complex system programming task. It typically involves C, assembly, and a bootloader like Grub. So the assembly entry point, you must write a small assembly file using NASM to serve as the kernel's entry point. This code initializes the stack, and so then the question is, can I get fucking, what's it called, to be a thing? So I want to get a, besides that, we're going to want grub for ARM. Is that a thing? Perfect. We like Arch Linux on this channel. We're a big fan of Arch Linux. Wish I was a real person. Damn. What are you, a robot? An AI? You've come to replace the real gluten-free? C kernel code. The main logic is written in C, compiled from with GCC using flags. Obviously, we can just use GDC. Like M-M232. What about a bootloader, though? What if I want to write my own bootloader? Custom bootloader? Oh, well now this is an even more complicated task. Because now you need to know like what the actual thing that you're doing is actually like. Writing a custom bootloader involves developing low-level software that initializes hardware, loads an operating system. PC and general OS bootloaders for PC-based systems. Bootloaders transition from 16-bit real mode to 32-bit or 64-bit protected mode. So does the Odroid N2L have a bootloader already? Because I know this is a thing that we probably should think about. Bootloader. Does it have a bootloader? U-boot as its bootloader, which must be flashed to boot media. Micro SD. All right, so we're gonna need some U-boot, and that means we have a good starting point for where we're gonna go with this. Universal bootloader. Is it? Alright, so U-boot. Actually, what version does it use? Perfect. Based on the AM logic SoC, system on chip, is the mainline, blah, 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 blah. ARC, or it requires cross compilation with the ARC-none ELF toolchain. I think a lot of what we're going to have to learn is how to get U-boot to work with what we're trying to do. U-boot compilation. Alright, so that's part of it. U-boot signing. I also need to get a monitor as well. So that's great, because I don't want to use the monitor I'm programming on, obviously. And I don't have another monitor anymore. I used to have like a shit ton, but I'm low on monitors. So acquisitions, we need to get a monitor. I should write that down, that I need to obtain a monitor from somewhere. Somehow. In some capacity. But anyway. So this is a guide, honestly, to... Or like, this looks like it's a guide on how to actually get U-boot onto your SD card. Or eMMC. Which I don't know what that stands for, but okay. That's a thing. So I'm sure somebody knows in the chat, maybe. But okay. And then, of course... 40 GPIO header. We'll use a lot of their information from, or how do we duplicate what they do? So custom bootloader. OS Dev Wiki provide tutorials on writing bootloaders from scratch. Typically involves setting up a stack, loading the kernel via the BIOS interrupts, and switching to protected mode using a global descriptor table. Embedded microcontroller bootloaders. In embedded systems, custom bootloaders are used for in-application programming, allowing firmware updates via interfaces like USB, UART, or I2C without external programmers. Okay. STM32, Qualcomm. Core implementation steps. Initialization. Configure hardware clocks. Communication interfaces. Validation check for a valid application image. And the information for the Odroid can be found over here on their website. And the Odroid N2L is right there. And we want to go ahead and find the documentation portion. Hardware information. We'll check that out. Boot sequence, partition table, and U-boot. So there's the boot sequence, which I'm interested in, and partition table. Probably will be interesting. N2L PCB revision, lot number, history. How to check year and month production with lot number. Why would we need that? Case modeling for data 3D printer. I bet you can't make that anymore. Huh. So yes, it has those. So how do you initialize this shit? What do you do for that? And I need to get a monitor for this to actually see that it does shit. This is where things actually, we'll see if I might have one lying around. I gotta have one somewhere. No more monitors. Oh shit. And the other question is, if I could get a bootloader to work on this thing, could I then attempt to get it to work so I can attach an external DPU to it? That's where things get crazy, because once I start learning low-level systems development, then I can do shit like that. Anyway. FCC certification below. Bro, fuck those guys, bro. C4 software. So the boot sequence. Stage 1, power cycle. This stage is aimed to fetch the bootloader software from the inserted board. Odroid C4/N2L offers 2 different boot stages to figure out location. eMMC, removable, custom designed by hard kernel eMMC5. Micro SD, removable UHSI. The bootloader in the eMMC. Oh, hey, and also because I wanna disconnect my device. Perfect. So there's going to be a boot partition and then some shit like that. It's going to be like, oh, boot from eMMC. That if it fails, it's going to try to boot from the micro SD. And then it's going to start the bootloader, which is the U-boot, which initializes everything apparently. Stage 2, the second stage to fetch relatively huge software binaries from attached storage can be accessible by the bootloader loaded at stage 1. In this stage, the system becomes more flexible to access various storage types and vendors. Even OS software can be loaded through network protocol or USB storage. Also, the bootloader offers a command line shell, so a user can run commands manually or set/store bootloader variables, and that's interesting. Oh, boot.ini. This is purely text-based file, human readable, editable by any editor. Okay, so it's config kind of. Boot.scr. This is a legacy script format of U-boot. And this is all for U-boot. So it obviously either we can't write our own. Well, I probably can't write my own. I don't know shit about what this does. We'll probably have to learn how to do some assembly shit and partition table. Well, that's an Android partition table, and I'm not going to set up some Android shit. Ubuntu is a better example. We have a U-boot, we have a FAT32 boot, and then we of course have a ext4 for the file system. Which, this is how Arch Linux structures itself, by the way. FAT32 for boot and ext4. That's how Arch for ARM would structure itself, the same exact way. Now, let's see. There's this, which is 512 bytes. There's this, which is 959 kilobytes, which is the bootloader itself. So very small program, probably written mostly in assembly. N2 series, perfect. So what exactly does a bootloader do to boot stuff? Yeah. That's the real question. It's like, what does the bootloader do to boot shit? But also, could we, in theory, boot D-Lang? ARC64 packages, Arch Linux ARM. So we do have a U-boot N2 for that. GNU Unified Bootloader. Okay. Alright, so this would basically just tell it to start up the system. Or, okay. Well, we could always just ask AI for the answers. but that's pretty lame. I feel like that's the right answer, though. It's like the modern answer. Let's just fucking ask. Let's just ask for the steps. Which should tell us what it does, exactly. Configure essential peripherals, UART, USB clocks, needed for communication. A firmware update check. We're not going to do that. Maybe not. No. So that's the second one. Firmware update and validation, and then deinitialize bootloader resources, and then transfer control to applications. So that will be the last step, is to try to transfer over to... so we don't need to really check for updates unless it's coming from a USB, so that'd be interesting. But then we need an example kind of to reference, which would be like really nice to have. Can I see the U-boot source code, maybe? Is there U-boot source code out there? I want to see the source code. I bet it's gonna not be that complicated. It's gonna be at least one file, please. Please just be one file. That way I don't have to search around and spend hours looking at these boot. God damn, there's too many files. So where does it start at? What's the first thing it does? The first thing it does, or according to this, first it needs to do hardware initialization. Which would be... what? Where does it do that? This is a question that I don't know about. This is why I don't like... maybe we'll try boot M. Alright, so maybe this. This will be a good starting point, maybe. Include make image. This is all C++, I believe, or regular. This is regular C. This is regular. It's a .c. It should be regular. Well, who knows? So they have boot.m, bootstage.h. We need to look at the H files. The H files is what we really need to be looking at. So we need to find boot.h because that's an assembly. Is there a boot.h? Boot flow C. Boot flow. Boot meth cross H. What is boot meth? Jesse, we need to cook 50 kilograms of meth. Where's boot H? Or maybe it's in a different area. It's in probably like boot m.h. Oh, boot M. It's special. It has an M on there. Include. Maybe in here. Crypto. Firmware. God damn. Well, everybody uses U-boot. Or so, yeah, that's how everybody does it. Bro, everybody uses this U-boot. U-boot shit. I was gonna say U-boot. Bro, what am I doing? Oh, I found it. There's a boot m.h right here. I can't open a new tab. So we're just gonna fucking hop to this. So boot m.h or underscore h. Then this is written in this is written in C, but it appears to struct boot m underscore info information. So there's a struct in here for boot m info. What is an H? What is a dot H then? It's source code for something. I know dot S must be the assembly, but dot H is what? File dot H. I'm unfamiliar with C. My mini lab, I think using this boot or U-boot. A .h file is a header file used primarily for C and C++ and Objective-C programming language. Declarations of functions, data types, and macros. Oh, that makes more sense now. So these are just functions and shit. So it's mostly written in C, not assembly. It would appear. I mean, so void m, struct boot m, and then whatever that is. BMI. There's another one, a type definition for int boot OS function. And then struct boot m info. Boot elf, struct. I'm using AM logic Mason GXL as DNS sync call. I have no idea what that means. I don't know what that means. I need you to explain. You can explain if you want to, but I don't know. Boot selected OS. And then, so that's the last step of what it does. Oh, there's even fucking, I'm stupid. Continue booting an OS image. Caller already has copied the image header. Alright, so boom. They put a lot of these in there. Boot m init. Set up boot m info struct with useful defaults. Set up the struct with default values for all members. So the function is void boot m init, and it's just this function. So then there's a struct, boot m info, and that. And then here's the next one. Struct boot m, information used when processing images to boot. These mirror 3 arguments of the boot m command. But how do you tell the machine what to do? Like, how does that work? Like, my brain's lost. I'm lost right now. My brain is lost. Because, like, how does that work? Like, what is this? What's my brain's fried. We're lost. What about boot meth? Handles. Oh, boot method. Oh, this is probably more important. This is for some object-oriented shit. Boot method. I remember something about this. Something needs to have a 0, and something else needs to have a 1. I know about this. I remember there being something with a bit switch, or some shit like that. See if AI can give us more information. That the hardware came from set up top box TV and turn in Linux system based debugging called Armbian to make my Docker lab. Oh. Configure the specific board using clone the repository from hard kernels. GitHub using the branch compatible. Compile the bootloader. Installation methods. Alternative. Bootloader on kexec that utilizes onboard 8. This allows the board to boot without an SD card or eMMC. So I should just plug in my Odroid N2L and see if it just does something. Then we could build off of kexec for my kernel. This allows the board to boot without an SD card or eMMC. Petite boot supports multiple OS boot configuration and basic hardware testing, although it has limitations regarding file system support, primarily ext2, 3, and 4. And SPI eMMC bus switching. Okay. So we don't want that. We want to try to set up building. We're not going to build a U-boot. We're going to make my own shit. That's where I'm at. So let's just switch this from that. Just make a custom bootloader. And this is the OS Dev Wiki, which is the best starting point, probably. Prefer to use their own software for everything, or wish they could try their hand at coding a bootloader. This page attempts to describe the step, what and why, disclaimer what you need to do. Alright. The bootloader ultimately has to bring the kernel and all the kernel's needs to bootstrap in memory. Switch to an environment that the kernel will like, then transfer control to the kernel. As the scope of this article is protected mode C kernels, I'll assume that an environment the kernel will like means protected mode. Which I don't know if we even have that. Since we're not gonna make protected mode, well, it's Odroid board. I don't think there's protected mode on this. Okay. You will have to decide where in memory you are going to load your kernel. Your kernel depends on, in real mode, the easiest way is to stay below the 1 megabyte barrier, which means you practically have 512 kilobytes of memory to load things. You may wish the kernel to be loaded at a well-known position, say 0x. Alright, so the first step is to decide where we're going to load our kernel. Which means I need to learn more shit about this that I have no clue about, even. Or actually... Yeah, let's just go with U-boot. Right, well, no, it's C, and I don't want to write C. So let's not do that yet. Maybe this is too hard of a task for me to tackle at this time. But I don't want to say that and throw up my hands right now. Let's try for this. Try for gold, you know? If your kernel is bigger or is expected to grow bigger than this, you'll probably prefer to have a kernel above the 1 megabyte barrier, which means you need to activate the A20 gate and switch to Unreal mode to load the kernel with A20 alone. You cannot have more than 64K above the 1 megabyte limit. Note that BIOS will still be unable to write memory above 1 megabyte. So you need to read stuff in a buffer below. So now we're gonna start streaming about your homework. Bro, this ain't homework. I do this for fun. I don't know what you're talking about, man. Alright, so we need... that's what we need. We need... to fucking... remember what I was thinking about. So thinking about this. Actually, Odroid BIOS. Odroid N2L BIOS. Is that a thing? By times 86 is instead it utilizes Petite Boot, a bootloader interface, accessed via a physical switch on the front of the board. This interface allows users to select boot media such as micro SD or USB storage and edit boot parameters. To access Petite Boot, you must flip a specific boot switch located on the board's front edge before powering on the device. And I'm gonna look at my board and see where it's at. If it's... oh. No. Where is that? Is it on there? So you need connecting BIOS and bootloader? Yeah. That's the first step. Is this, I mean, at least there's a bit of documentation on what even is the fucking bootloader for this thing. Front of the board, is that the section with the USB or the fucking... the one shit? UART? Or is that not even a switch that's, like, actually there? Is that just a switch that's, like, a transistor switch? Elaborate. Tell me what you know. Odroid N2L uses Petit Boot Linux-based loader. Boot selection in Petit. The primary method is a physical boot mode switch on the front of the board. What? A physical switch? Like it's actually there or no? Is it like actually a button I can fucking press, or is this? Because I know the Raspberry Pi is a button I can press. I can press the button on the Raspberry Pi. I don't know what the button does. I just know it's there. Is this a thing? I can just press a button? Or, no, I don't think this is what this is. I'm pretty sure it means a metaphorical physical switch, which is like, what? Metaphorical physical switch? What the fuck does that mean? MMC mode boots directly from eMMC. This bypasses Petit Boot for faster startup. SPI mode boots from SPI flash memory where Petit Boot is stored. This grants access to the Petit Boot menu for OS selection and configuration. I think what I need to do is actually just set up the setup so I can open my Odroid and see what happens. This will be a fun experiment, I think. We're going to remove the Raspberry Pi from the area and then make sure that we have the SD card. Then we're going to place down this shit. Pull out this cable because it's no longer needed. The Pi is fucking annoying. Pi is annoying cable. Alright, and then we're going to use one of the memory cards that I have, which we're going to use the one that came with the Pi. Pretty sure I already have ARC set up on this one for fucking the Pi, but that shit didn't work, so. Then, also, we need to set up a power connector for that. Power connector, where are you hiding? I like power connector. Alright, we got the power connector. We need the entire HDMI shit. So more HDMI cables. HDMI cable galore. Ugh. Get in there, bro. Alright, I'm setting up the shit so we can actually just try it out and see if we could just get it into the Petit Boot or whatever it's called. This cable is gonna just not be managed. Less cable management. Alright, so that's the power cable. Power cable's now plugged in, ready to go. Then I just need to get the HDMI splitter set up, and then we should be good to actually just plug all this shit in. Well, as a matter of fact, the HDMI splitter is a dumb idea. Let's just skip the whole splitter step and just plug straight from the thing into the thing. Make it easy on me. So let's do that. Boom. Alright, we're good to go. Let's get it, dude. Plug that shit in right on that one. And I hope that doesn't break anything. Linux Christ, bro. That's plugged in. And now all it needs is power. So actually, this is a really long cable for what doesn't need to be that long. Let's go ahead and use a shorter cable. Let me use the short cable. That's my bad. Me am stupid. Yeah, I'm caveman. And the only reason I say we have to use the shorter cable is because it's so long that it's going to cause issues and fall off. And fall off my desk would be annoying. And plug that in. So I got that plugged in, and then it's on to the power. And plug in power. And now it's gonna do nothing. Oh, is it doing something? Okay, let's go ahead and open up the capture card or add it as a source. USB video. Okay. So that's nothing. Does it need a SD card before it will boot? We're going to put that in the bottom corner right there. That's a good spot for that. Alright, so if we unplug the power supply... Maybe I used the wrong power supply and fried it by mistake. I sure hope that that's not the case. Then we're going to try and put this shit in the side. Alright, let's see if we can try getting the Pi OS to fucking work on Odroid N2L. No. What the? What the hell? Damn, wait, it's not even showing up in the stream? Is that it? There. Is that showing up? Oh, now it shows up in the... Okay, never mind. I'm stupid. So there's no... that's not gonna work. Or maybe it has a power button on it. I'm just fucking stupid. Let's try to find a power button. I can just press. There's a slot that looks like it says eMMC on it. Maybe that's what we're looking for, but Odroid N2L power button. Doesn't feature a power button. Wait. Wait, so how do I turn it on? As 5 are insufficient for booting. Ensure the power supply is securely seated and check for any LEDs. Well, it doesn't feel warm or anything. That's not a good sign. Try this out. Oh. Whoa. No LED light. No petite boot. Is the power just not plugged in right? Maybe that's it. These are the questions. Step one's just to get it power. Which that did something. Plugging into the wall. So the power supply works. The Odroid must just be fried. Is it fried or some shit? Is it fried? No, I could have tried this on the Odroid M1S, but I think what would happen with that is that I'd get to it and it'd be like super complicated because not only do I have to worry about integrated GPUs and other hardware like that, but there's also a node processing unit on that. And I didn't realize that at the time that I got it, so I now have a board which you could technically, apparently, something AI something or other, which I don't really want to mess with node processing unit at this time. And there's nothing new going on with it. Frame rate 5 frames per second for this. Try toggling the boot mode switch at the front of the board to an alternative position. Alright, let's try figuring out where the Odroid N2L puts its boot. Boot mode switch. Instead, it relies on SPI flash memory containing the petite bootloader to manage... shit. Which acts as a boot manager, allowing selection of eMMC, micro SD, or USB storage. Or fails the system defaults. Okay, we're gonna just choose a different board, but I would love to use the Odroid N2L because it's just a board that doesn't really have much purpose. Set boot priorities, enable auto boot, or select OS images via petite boot graphical interface. Gonna hide that for now. So, wait. There might be a switch. That's that's the original Odroid N2. Bro, some of these images are so cool. Like, what are these guys doing? What are they doing? Lots of stuff. Let's see if the other boards have what we're looking for. Well, the M1S certainly doesn't have what we're looking for, so we can rule out this board. And the Pi has a button. And the button on the Pi is probably what we want. I think we should probably just go with the Pi then, even though it's probably more useful than the Odroid N2L. Let's just figure out how to get U-boot set up then. So we were looking at U-boot, and that's going to be... I mean, obviously it'd be cool to... It'd be cool to write our own bootloader, but I don't even know what I'm doing with the kernel. So let's start off with U-boot and... maybe we could try to do a bootloader. Flash the SPI images to an MMC, I suppose. Maybe actually. What even is the MMC? Odroid. Because I saw a place for eMMC, but booting from and eMMC modules, while eMMC providing significantly micro SD cards are limited to approximately 15 megabytes per second and prone to wear from heavy I/O. eMMC modules offer speeds up to 50 megabytes per second and are roughly 7 times faster read tests for large files. eMMC module, you typically need a compatible bootloader to flash the operating image. Yeah. Oh, that's also interesting too. Alright. Well, I guess we could just try putting... Yeah, and I see where the eMMC goes. Or SD card maybe works. We're gonna have to write it on the SD card for sure. That's what it wants me to do. So we'll have to do SD card. And this one already has 2 partitions on it. So we're gonna do some shit with this. We're actually gonna do something for once. Alright, so we're gonna do ls USB. Oh, actually, what was it? Was it actually ls USB? It was LSBLK. That's it. That will give us our SDAs. That's what we're looking for. Because that's a mass storage device that's not connected. So we're going to want to mess with this. See, there's already 2 partitions on here. Your OS goes in the second partition, but the first partition is the bootloader. So we'll just try to write that first portion, and then our operating system, we can write that later. Hell, we might even be able to study how they do, or how... Well, actually, let's download the U-boot too. Okay, maybe not. Or can we grab this from Arch Linux? Maybe I could just Pac-Man grab this shit? I don't know. We'll have to figure out how to grab this, but... Oh, package. Source files. Son of a bitch. Download? That didn't work either. But I'll need to use Tor or some shit. Or something. Somebody knows how to do it. Somebody will be able to tell me how to do it. But we're going to need to use fdisk now. We're going to do fdisk. Oh, sudo fdisk on the right download text. Yeah. It won't work. Sudo fdisk, and then we're going to do /dev/SDA. And we just want to do that. And then password. So now we need to do O to format it. And I don't remember the rest of the parts, but that's how we do the first thing. And we're just going to hit W to finalize. So it will format it. Actually, shouldn't be that hard to do the other shit. We could do help, maybe? Like -H. Or H. Okay, never mind. Oh, I'm dumb. Alright, so now... Yes, we did O. O dumps the disk layout to sfdisk script file. So we're going to want to create a new... Oh, create a new label. Oh, so capital O dumps that. Okay. So we did O. We can do... a new partition. So we've got a partition table. Then we want to make... What's a bootable flag? Anyway, for doing Arch Linux, what they did was like... We had to make a partition, so it had to be a partition. Change partition type, resize partition. was like new partition. Where's that? So we'll just look at generic. Change a partition table. Maybe it's that one. We'll check that one. Ah, N. Add a new fucking right in front of me. N. We want P. We want 1. We want the first sector. We want to have it be not the default. So we want to put 1 and capital G. Hit enter. Or no. You want default for that one. Last sector. We want not 1 gigabyte. I don't think we want that. Because this is just the boot partition, right? So the boot partition should be under a certain amount of kilobytes. It can't be over 1 megabyte, right? Unless you have some special bullshit going on. But I think it'd be hard to do that, so let's just go with 1 gigabyte, probably. And then we can have a bootloader in there for... Yeah, it should be enough. We could go with 4 megabytes. We'll go with 4M. This is my own shit. Oh, of type Linux. Never mind. Let's just delete the partition. D. Selected partition 1. Partition 1 has been deleted. Change the table, or was it GPT partition? Sun sounds like it'd be like Java or some shit. DOS, DOS. Erix? What's an Erix partition table? What the fuck am I even learning about, bro? I'm learning so much shit right now. My brain is throbbing. Erix SGI supports 16 partitions and uses a unique structure around mandatory volume header and volume partition. Fascinating. What's a GPT partition table? I'm learning shit I've never learned about before. Modern standard for defining partition structure on stored devices. Okay, so probably not what we want. Oh wait, it is an integral part of unified extensible firmware interface specification and utilizes global unique identifiers GUIDs. Overcomes the limitations of MBR by supporting disk sizes of up to 9.4 zettabytes. Jesus. So like Facebook, I mean Metaverse. It's like Meta. It can support their disk drives. I want my disk drive to be 9.4 zettabytes. What the fuck? Bro, that is crazy. But partition table, we don't really care about GPT. We want that Sun partition table. I hope it's like Oracle, bro. Oracle? Corporate slopical. BSD Sun disk label is Oracle Solaris. Knew it was Oracle, bro. It's got Sun written on it. Buh. Alright, so F disk. I see. So, if we're not writing Linux, then what are we making? How are we gonna put a thing on there? None of these are what we're looking for. Well, I guess maybe it would be GPT. I probably would want. We could try GPT. Because we're not gonna make a Linux table. We're gonna make Fish OS. It's gonna be beautiful. Well, it needs some kind of memory management too. Very interesting. Well, maybe we don't need to do that. We just need to format it. We're just gonna hit W. W on it. So now it's a nothing partition. It's a GP. It's an MBR partition, DOS table, with nothing. MDR is a legacy partitioning standard introduced in 1983 that stores partition information and bootloader code in the first 512 megabytes. It is limited to supporting disk drives up to 2 terabyte in size and allows a maximum of 4 primary partitions per disk, often requiring extended partition to create additional logical drives. UEFI systems requiring GUID partition table for installation and booting. A common error the selected disk has. Okay. Let's try it again. Let's try out fdisk/dev/. I just kind of got nervous because I didn't know what I was doing. So we're going to hit O, and that's going to be new. Yes. We're going to hit the N button. We're going to hit primary 1, default, enter, and then we want gigabyte. 1G. The fuck am I? Who's sending me that at this time? Who is sending me the messages? Confirm that you are not a robot. This is an amazing message. Thank you so much. Greetings, fellow Earthling. Yes. Greetings. I am getting pinged so much on Discord for nothing. Okay. So we have, apparently 1G is out of range, but that's, oh, you know what it is? It's plus 1M. That's what I wanted earlier. But we're gonna go with plus 4M. See, M is the size. Nice! Now, we want to hit yes. We want to change the signature of it. So that would be T to change a partition type. L to list all. Oh, holy shit, bro. I'm learning a lot about fdisk right now, bro. What the fuck? IBM ThinkPad? Holy shit, bro. fdisk. Holy fucking shit. We want FAT32 though. So yeah, diabetes for this device. We want. So VFAT was like W95 something or some shit. We want something else. But that's pretty cool. Like, look at all these options. I don't know what half of these would be. So, EFI, wasn't that one of the things we were trying to do is get a boot partition, right? So you want an EFI, right? Was EFI what we're looking for? What does EFI stand for? These are the questions for somebody who doesn't know anything about computers. I am stupid. EFI, tell me what it is. System partition. I want to know at this time. Tell me about the system partition. I need to know. Oh, firmware interface is a partition on a data storage device that is used for unified. Okay, so we can't use an EFI. There's a GNU herd option. Other thing. I keep getting messaged from people. Okay. Shut Shut up. BC/IX at Cronus FAT32 land step. Oh, well, we are looking for FAT32, but we're not looking for at Cronus. Ah, W95. 0C. But that's LBA. What does LBA mean? So, I'm pretty sure that's also what we want. What is that? LBA? Legacy identified fire, logical block instead of legacy cylindrical. Okay. We're on to it. So we want a W95 FAT32 LBA. Hello. We want that. So we want 0C. Nice. Perfect. Now, we need another new partition. And this one's going to be the main partition. Unless I want to add extra bullshit. But, you know, keep it stupid simple. So let's do that. Follow the Arch Linux logic. N. Hello. Hello. I'm here now. At all times, I'm here. 1. Actually. P for primary. I'm full of aura. 2. What does that even mean? Default and default. And then I need to do a type. Or do a, well, it's not going to be Linux. It's going to be custom. So how do I make a custom one? Custom setup. Oh. And, of course, this is also how you do this shit. Which is really easy, apparently. Like, apparently fdisk is so easy to do. Fdisk, guys. If you don't know what you're doing, just type in -H and everything will tell you what to fucking do. If you don't know what you're looking for, then you just do -H again and it tells you. Bro, I'm so good at Linux now. I'm a -H user. I'm a super user doer, bro. The master super user doer. But yeah, I guess we could make a Linux one, but we don't really want a Linux one, do we? So like, how do you make a custom Linux, bro? So custom. So like, would I just generic OS partition? That's what I want. A generic OS partition. So the partition table is DOS, which means the most generic one, and then contains a generic kernel image and generic RAM disk, while system partition holds the OEM system image. Distinguish. Okay. Linux extended. DOS access, DOS secondary. Any CDOS? That's not what we're looking for. Although /boot may be separate in Android 12 Plus, the boot partition contains the generic kernel image and RAM disk. Okay, that's not what I'm looking for. I mean, I guess if what OS partition supports custom OS. For creating a custom OS in, okay. Using ext4, so we want to change it to an ext4 one, probably. So we'll hit T and then we'll try to find ext4. Yep, that's what we'll do. We'll leave it as a Linux W95 LBA, and then we'll leave this one as that. And then we'll do T. That gives us partition number for 2, and then L to list. And that will tell us what's available. And then remember, we're looking for ext4, so look through all of them until you find ext4, which should start with an E, so it should, and end with a 4, so it should be pretty easy to find. extd, so 0f would be extd, but we don't want extd, we want ext4, bro. Or we could do BTFRS or BTRFS. We want to try that BTFRS on this shit and fuck everything up. EFI. Risk B. Boot wizard hidden disk is secure multi partition magic. Bro, there's too many of these. Too many choices. ext4, bro. Can I not just have a simple ext4? We could do empty, like empty 00. ext4. I don't see it in there. W90 Windows 95 FAT3. How, oh, that's crazy. Is that what W95 is? Well, this is also W95. So Linux block array, right? fdisk ext4. If I had to fix something with fdisk, I think I would know at least slightly what I'm doing now. I've in the past had to use fdisk for some shit, but I never knew what I was doing with it. But now I can figure shit out via gdisk or with a G or fdisk with a GPT label. Windows partition. Mount new disk ext4. Okay, so create a mount point on the file system, which is to yeah, this is shit that was covered with the Arch Linux stuff when I was reading that and did that a few times. That's kind of why I know what I'm doing with fdisk, is because I did it a few times. That's also why I did it with Arch Linux yesterday. We were able to do that shit so easy, is because I've done it like 7 times already. So I didn't have any problems because I was able to easily just go ahead and do that shit. So that's something I'm going to try to do in the future, is try not to jump into these with no clue what I'm doing and have at least some experience with the subject. Although this is this is us doing the same shit we've been doing. So NTFS, that's something I remember. NTFS, that's one of the ones, but that's for like Windows, I think. One for logical, except the default format with ext4. Oh, that's right. You don't need to do the whole type shit. Actually, we're gonna just nothing. No. So just aliases Linux 82. How do I not do that? M for help, please. Help me, please. Please help me. Change type of partition Linux to unknown. Oh god. What the hell have I done? Well, okay, I guess it's an unknown partition. So at this time, we now have an unknown partition. We're gonna just hit W now. So the next step is to use mk.fs to actually do that. So you would do sudo mkfs and then do your /dev. So then what I can do is mk.fs or make mkfs.ext4, right? And this is one of the other things. I kind of forgot about this part, but you can do that /dev/sda2 for my case. Permission denied while trying to determine the file system size. Very interesting. Well, that's a pseudo interesting And then boom, that creates our new file system right there. So that should be what we're looking for. And hit enter. It's going to take a minute to do it because it's such a large area to do on such a slow device. So that's done. And now we've created an ext4 file system on that device. Which means whatever OS we do produce needs to use that specific file system or partition. So then our own bootloader background theory. Well, I mean, I kind of already know what the heck it's supposed to do. What I'm curious about is how the heck you get it to actually interface with the hardware. I mean, I guess what you would need to do is just know ARM assembly. I do have the shit we need for that, the information. But I don't know exactly what we would do with the ARM assembly to get it to do stuff. I think it might be specific. It's not specific to the chip. It should be standardized. But I mean, I think this will be enough. So if we pull out the SD card, and now it's done writing and shit, we should be able to do that fine. And we never connected it, so we never mounted the file system, right? Because we never did the mount. And then if you do mount it, you do U-mount to unmount it. So it's not like unmount, it's U-mount. I know that for a fact. Insert my SD card, bro. I love the SD card. Love the Linux, bro. I love the Linux. Oh, yeah. I'm a super user doer and about to super user do some shit. Alright, I'm gonna plug it in. Whoosh. And see that nothing happens. It does nothing. Interesting. Très interessant. See if that's doing anything. Because in theory, it should be just, what it should be doing is like actually loading up the petite bootloader that's already built in on there. Although, maybe it doesn't have that, which would mean it needs to have that available to it. And I'm guessing petite bootloader is a platform-independent bootloader based on Linux kexec reboot mechanism. Similarly, primarily used in PowerPC/Power systems such as Sony PlayStation 3, which is not surprising. That's basically computers are consoles, so very cool. Petite boot, and then releases. We'll just grab this shit. Source code, or I would like to study both, but honestly, grub parser. It's not gonna work on ARM. It's not an ARM. Let's try to get the Odroid specific one. See if there is an Odroid N2 one. kexec Odroid. Utilize petite bootloader based on pre-installed on the boards. Yes, but we don't have an N2, so we have the original. Well, we have a smaller N2L, which is a board not in production anymore. So, petite boot, yet another bootloader based on kexec. Background, the Odroid N2. Oh, and this is exactly the board no, that's not the one we're looking for, but it's similar. Released a batch of engineering samples so you can directly boot. We also have a couple changes on the source code of Petite Boot as well as kexec tools. Has been uploaded to GitHub, being used to complete the SPI, which consists of U-boot, Linux kernel, and RAM disk, which is limited to 8 megabytes. Code. U-boot parser. M4. What's an M? What? M4 lang? Is a general purpose macro processor language included in most Unix-like operating systems and is a component of the POSIX standard. Oh, quite interesting. Yak, Lex, and other. Which usually this shit's wrong anyway, for the most part. How much is there to this repository anyway? Like, how much code is in this? Like, can I get a file size? So this should be what we're looking for, though. Use non-recursive like functions, M4 Odroid, discover, add U-boot parser. A lot of shit in here. And those are, okay, here's udev. So it includes all of this shit. So that's the last one we want to look at, but we want to look at these H's, like boot.h. That will give us our answers to the questions we're looking for. Oh, shit. So there's an enum at the end, which is load decryption failure, 252. Kexec invalid. And then kexec load. So there's like error codes. They got like an error thing. And if it throws one of those, then it enumerates whatever that one is. So if it throws 252, just kexec load and then gives all of that shit. Super interesting. Struct boot task. So they're declaring a boot task. A boot, or call it, actually they're making an object for it as well, it would appear. Although I'm not familiar with the C, if a C struct would be doing that. I'm pretty sure that's, I mean, in D-Lang, if you have this, means you're creating. However, I suppose this is just like anytime they call that, then it's interesting. How will you find your kernel? If you're, what else could you need to load? Mainly depends on your what's in your kernel. Linux, for instance, requires an additional init rd, which will contain the initial or the initialization process as user level. If your kernel is modular, the boot function returns the struct boot task. Okay. Yeah, let's go back to that boot h. So it returns the struct boot task. Oh, wait, yeah. So then discover boot option. Hold on. So that's a function called boot. We're probably just going to set up U-boot and see if that does anything for us. Well, I don't know if I... there's so many choices. I don't know which one to make. Should I make my own bootloader or just use one that already exists? Try to figure out how to make it work. Init, RD... A lot of shit in here. These are just putting in these different functions from different places. boot task. These are those one things. Probably referencing the boot.h. No, there is no boot.h. Oh wait, right there. It'd be really easy if I just knew what it was from the ground up. BIOS interrupt 13th. Get about it with Ralph Brown's interrupt list. Read entry protected mode. To enter protected mode, you should first disable interrupts and set global descriptor table. And after... Okay, so we're going to be doing assembly. This is a starting point. So ready. Entering protected mode. To enter protected mode... Oh, wait a second. There's even more shit here. There's this shit. Loaded gathering information. So those are like assembly things. Like writing it in assembly. Interrupt 13H. Make sure you know how, or now know the floppies may fail 1 or 2 times, that you cannot read more than one and then a track at once. You have to use CHS addressing and you're done. To read from the hard drive, which is preferred way these days, also used by CD-ROMs and USB sticks, you want int 13H drive number. Like, it'd be nice if there was a data sheet that just had like all of the shit I needed. If you need guidance, check low-level ASM. Awesome! What? Is this actually good? Whoa. Let's see if we're looking, very good software. Server operating systems. And it said assembly or C. It's mostly written in assembly then, I'm guessing. What the hell? Oh. Or actually, I know a better starting point is, I know a better starting point for us. I think we need to start off by learning assembly first. Which is not hard at all. That's actually, should be pretty easy for me to do. Or... Assembly Studio? Is what I'm looking for? No. This is what we're looking for. Develop. Software development tools. Yes, this is where we're going. This is where we're going to start at. No. We don't want that. Buy ARM developer tools, of course. Damn. No, we need a fixed virtual thingy. Or something that emulates what the Odroid does. Fixed virtual platform. That's it. For the Odroid N2L? Question mark? Community guidance indicates that VirtualBox does not support the generic ARM platform required for the N2L. Recommended, yes. Kernel-based virtual machine to emulate, while the N2L uses ARM QEMU. Wait, so what is it saying? Like some shit about, instead of virtualizing, you need to install the operating system such as. No, I want to virtualize because we need to program for it. Right? So we can get a simulation, kind of. How do you simulate a computer system in your computer? That's what I need to do. Maybe we need fixed virtual platforms, or like. Am I lost? I'm pretty sure we're lost now. We've gone too far. We've gone too far, I think. Oh. Code. Or discussion? I'm good on that. I'm good on that one. Let's go ahead and see what else there is. Game emulations now. Oh, VirtualBox. I see. To emulate or virtualize systems. Running ARM VMs. Okay, that's a good starting point too. But I don't really want to set up a virtual machine. Really. I don't want to do that. It's not what I want to do. It's a pain in the ass. And like, what am I supposed to do to test it? Because we can't get it to like do anything really. That's the thing with this one. It's like, I think it'd be easier to do this on a Raspberry Pi, because then you can at least see the light flashes and does shit. This one, you don't see that. So it just kind of sits there and does nothing. Let's see. Mainstream, and also want your code, your bootloader as a learning experience to understand how they function. There's the bare bones, but this would be a great example to see. Right, a simple kernel. Okay, let's try that one. Let's see if this has anything for us. Assembler. NASM. Assemble instructions into projects. We'll use that. GNU assembler. As part of the bin utils package, GCC generates and automatically invokes GAS. Cool. Oh, I wonder if it can do GDC as well. We're probably gonna write most of it in assembly to get it started. And then the rest can be D. As we get higher up, we can do more abstract shit. Or just, we should start by studying the actual... This is a next month project. I think it's a next month project. You see, reason I think this is because when we go ahead and do... like, let's try building any of the fucking... Or try to figure out what we're even going to do. Because I think it's going to use a lot of assembly. And I want to look at what D-Lang even looks like in assembly. So we can build a framework that's going to support it pretty well. So we'll hit compute this section. Downloads, documents, bin util. No, we're not looking for that. Actually, we'll just do it here. CD slash or this slash desktop slash D tools. What the heck? Oh, I did that wrong. Slash desktop slash D tools. And then ls. Then we have all of these we could look at. We're going to look at calc. Or we'll write a new one. We'll write a new folder. We'll call it a hello world. Yeah. So we'll make mkdr ls cd hello world. Oh, look how good I am at this shit. Next thing you know, I'm gonna be using Nano to write my code, bro. Not even joking. I actually am considering doing that right now. Let's go ahead and tmux then dash h. Oh wait, split dash h, and then we're gonna do nano in this directory. Or actually, yeah, no. Can you make a file? MK file? No, let's just do nano. It'll do it for me. We're gonna nano hello world dot d. Oh my gosh, bro, we're actually using this. And so we're gonna, is it import? I'm pretty sure it was import standard dot standard IO. Then we would do the next step. There's gonna be void main, and then you do this. Or, yeah, you put these in here, that, tab. And then we'll write out the next thing, which is going to be write ln hello world, and we want to try to get the GDC compiler to where I can assemble this. Go here. We can write out a dot slash or dmd hello worlds. Actually, we didn't even save it. It's a hello, yeah, so before we go do that shit. Control S. Control B, switch over. DMD hello world.d. Nice. And then I can do one more thing. I'm gonna do /hello world. Oh, yeah. I got that shit real fast. And now it's time to try to invoke GDC, which failed. But we need GDC -h or --help maybe. Here we go. I don't know how to scroll up though, and so that's kind of shitty. Compile and assemble, but compile only. Do not assemble or link. Okay. So compile only. So we can do GDC hello world and then dash capital S. Or dash C. Dash C. Oh, so it's a warning, and then let's just ls. So hello world.o. What's the .o file? We're gonna figure out all that other shit later, but maybe for now. We'll try out this file.o. Machine code generated from a single source file. Alright, so that would be... Alright, we're gonna get Control B. Is the compiled output. Okay. I don't see a .s file though. How do I get an assembly output? Let's see. Let's see if I can figure that out. Because if we can figure out how to do it with this, then we just need to get a cross compiler. We can start learning how to do that shit. Compile dlang to assembly or some shit. Or you need assembler, right? With the dash output dash s flag. OBJ dump. Okay. Let's try out OBJ dump. Aha! The French is taking over now. OBJ dump dash D. And then our program .o. Whoa! Holy shit, bro! But I can't really scroll up. But holy shit, we've made something beautiful. Holy shit! What the hell have we just done? It's so fucking beautiful. Holy, oh my gosh. Technically transpiling. Now I think this didn't do transpiling. I mean, I guess this is some weird shit right here. I guess we've done it in a way that's probably not the best way, but I mean, I guess it somehow works. there's a bunch of this in here, a bunch of that in there, and it's all prefix of underscore D3. A lot of move. They do a lot of move to do this, but I don't know. So how do I... Let's go ahead and check what the... Hold on, I got an idea. Control B. Control X. We're going to continue with this setup, this format for the video. This is absolutely insane that I'm doing this, but... compiled and then disassembles it. Oh. Perfect. And then we could also have one down here where we're gonna do other shit. So we do dash. Bro, this is an insane setup right now. I can't believe we're just writing code in the terminal only. Terminal only mode, guys. This is my new IDE. We're going to be writing only in the terminal for now on, for the rest of the playthrough. Yes. What command do I want to put into my terminal? ls. Okay, so what we need to do is go back over here to our other side and do the exact same shit we just did. But we need to pipe the output to make a file. Or however we do that. Something to make a file. I don't actually know how to do this. We're developing in the most interesting way possible. Only using the terminal. We're developing on full Linux mode. Super user doing. Alright, so we've got our file.o. We figured out how to do that. Then we need to make a file from a command output Linux. Because I don't actually know how to do that shit. Ah, perfect. No need to pipe. Nano file name. No need to pipe. This will work. That should be it. Why did I hit control? Why did I hit control S for some fucking reason? Oh, did I crash it? Have I destroyed it? Uh-oh. Oh, guys, we've really fucked. Oh. Never mind. I just did something weird. Wait a second. Does it, like, pause or some shit? Oh! The hell? Okay, well, now I can... Now it works. Alright, let's go ahead and, ls. Nice. Look at that shit. Damn. Oh, look, so there's a file format, and it says it's ELF64 times 86-64. So, like, it's a we know what that's like a partition, is the ELF partition. So that's something interesting to learn about. We should look into it. I don't know what I'm looking... Okay, so we have something called dmain, which is a function of some kind. And then we have, something else called main. And then we have something called object, D6 object, which D4 core internal array duplication. This is pretty cool, actually. Core 8 internal array duplication. These for like something interesting. There's some hex going on and some other shit. And this is why I should not use nano for this. Disassembly of section dot text. So some of these are like not important, kinda. Like some of these things are like you don't need to worry because some of them are like headers from the actual command. And there's call. I don't know what the call function. JE? Bro, I don't know any of this shit. That's why we need to pull up some fucking documentation on these. Or just start being like, what does move do? And asking AI the question, since AI usually knows. So call times 86 underscore 64. Ooh. Current progress. Since I have no clue about kernels, also, where you currently... We're doing our initial research to see if I think I could do it. That's the phase we're in. Initial research. Do I think we can do it based off of this research? And then when I say no, probably not, jump equals means... And jump and J and E means jump not equal. Yeah, I have no clue what jump... Well, that'd be like... Call is used to invoke procedures, saving return addresses on the stack and transferring control to the target. It supports near relative calls using 32-bit displacement sign extended to 64 bits. Is it like... Oh, percent is a register. Moving. XOR. Where does it write the code at? Where's it like write? How do you write? How does it even? Bro, this shit's so unreadable to me. Why is there a crone all of the sudden next to my name? I don't know. Oh, crown? Oh, because you're the #1 commenter right now. This is so interesting, though, seeing what it looks like, kind of. Bro, or rex.w call. Obviously, assembly is something I shouldn't write in, because I think if I wrote an assembly, we'd probably blow some shit up. Oh, and also the top part is important. Checked int. Internal array utils. I feel like there's so much bloat in this language, too. I feel like the language is also just bloat. I feel like you'd write it better if you just wrote the entire thing in assembly. Standard IO. This is the standard dot standard IO part. Okay, very interesting. Maybe these are all the functions? No, these are not functions. Functions start... Oh, wait. This might be a function. Like, this part might be functions. Pretty sure this is like a comment. but I don't actually know. So don't. This is the right out. I know what this is. This is the part where it writes the line. Oh shit. Common sense. Okay, so write ln. So this is the write ln. And you see it's got all these values. So it's calling for standard IO, and it writes each individual character, I'm guessing. So if you were to take this hex at the end, I think, or is that not even hex? Maybe that's a hex. That's a hex. So if you take the hex of 40 and convert it into whatever the fucking code for the console output is, which I think is UTF-8. It doesn't say anywhere. But I think it's UTF-8, which is what the console uses. So if we take the hex code and put it into fucking a search, let's see what that even is. (0x40 UTF-8). At. But it might also be ASCII or Unicode. I don't remember which one it could be. My arc cursor doesn't work super. Oh, wow. Okay, finally got it to work. About 0x50. Is that also important? Character table. 0x50. Okay, let's just look at their character table. Oh, never mind. I don't want to be a victim of the fucking internet. Maybe I think I'm wrong. I think my hypothesis is wrong. So if we were to just put this and copy this into AI, bro, control copy that. Where's the copy button? There is no copy button in Nano. This is why I shouldn't use Nano. Anyway. Oh. There's 1,000 lines in there, by the way. Control X. tmux kill dash server. If only I knew how to close the terminal using the terminal. Bro, that'd be so meta. We'd be at an advanced stage. We're gonna pull out all of my better tools. The world's greatest toolkit of all time. Did I actually install Kate, finally? Because I like Kate better than the other ones. Kate's better. Kate can go above all of them. Bro, VS Studio, AI, slop. Other studio doesn't have the same shit I'm used to, so I'm just gonna stick with K Advanced Editor. I think this is the one I like the most. In fact, it might even be the best text editor for Linux. Although, I don't know. I don't know, Alt F4 works for me. Interesting. New file. Use Emacs. Emacs? Oh, I should try that out. Yeah, that's actually a good idea. I tried VIM, but I didn't like it. So we want to go ahead and find tools. It'd be more meta if I could open up Kate with a file in the text editor or in the console in Alacrity. Bro, I have too much fun with the console, bro. I have too much fun with the console now. I have to be stopped. So dtools, we're gonna take hello world. Where's it at? Bro, I made it exist. I brought it into this world. I don't think assembly is a language that I'm going to enjoy. I think it's one that I'm going to absolutely... Look how pretty this is. Oh my god. So pretty. So dmain. Disassembly of text section. Oh, bro. So much more readable, too. Can you not open a file running kate.file name? Maybe. Oh, that would probably work. But I'm not that familiar with my terminal still. I'm like barely capable of making tmux, bro. Or fdisk. Like I know some things a little bit, but I don't know enough. Like I'm like intermediate, I feel like. Intermediate beginner level Linux. Array duplication. Like what does this even mean? Can we let's get some AI on this shit. Get some AI on this. At this time, we will ask AI how to figure shit out, bro. Paste. Paste it all in there. Hand it to it. Hand my assembly to it. Whoa. Loop control structure for a for or while loop. What? Okay. Bro, this is it. We're hitting peak vibe code now. Soon the AI will be making me write the code for it. Soon I will be the AI slave. Wow. Oh, my brains. I can't wait for this weekend because then I'll actually be doing productive shit instead of fooling around with things that I can't get to work yet. Wait. The O-droid is warm. That means it is doing something. It's doing a thing. So we did achieve something. It made the O-droid warm to plug it in, but it didn't do anything else. So yeah, that's an interesting starting point. So that's a for while loop of some kind. Counter I, stored at RBP0x in the RCX register, compares this to counter I with the value of a variable stored at RBP0x30, which was with the value of, okay. Oh, wait, hold on. One of them is RSP. What is RSP? Function of the first argument, RDI. This is not a good starting point. This is a good intermediary point, but not a starting point. This is in between points. We need to be using our brains here, and to kick my brain into full capacity, we'll have to use some documents. We have documentation for 86 times 86. RCS, RBI, RSP, RBP are all 64-bit registers. Because I need like some kind of background at least. So, did I have? Oh, yes. Wait, what? What is a CS107? Like C# 107? Is this not what I was looking for? Where did I get this from? Oh, here we go. Stack pointer. RSP is a stack pointer. RDI is a first argument. RSI is a second argument. Oh shit, this is so useful actually. Holy fucking shit. Let me pop that on that side so I can just look at that shit for like 10 hours. Alright, so if we... There's an instruction suffix too. Alright, so there's a common instruction called move. So, get off my screen, bro. Oh, there, we have room for it now. I can put it over here so you all can see it as well. Alrighty. Let's do it. Computer Science Class 107 at Stanford. Oh, so that's where I got this from. Must have downloaded it from somewhere. And ended up... I don't fucking know where I even got this one from. But it said times 86 by 64. So I was like, okay. That's the one I want, probably. So push, is that in there? Do they have a push? Oh, jump not equal. Jump equal, and they have a label for it too. What is the label even? So how do you use that even? Like a label? Then you have add, subtract, XOR, which is a XOR something. Oh, there's even more information on the other side. So let's see, for like jump not equal to. What is this column? Oh, push, add to this top of a stack. There we go. Ah, perfect. So add to the top of a stack. Earlier semicolon at the end indicates that that is a table. Table? So push source, src, add to top of stack, and then mem, and then rsp. So, or equals source. Or maybe, oh, hold on. So they're pushing rbp, and they have 55 in front of it? What is the 55 for? Or is that's the line? Or what the hell? There it is, a label. Right. Where's the semicolon at? I don't see the semicolon. Push add to the top of a stack. So they do that at the start of each of them. These are all a bunch of loops. So d underscore d main is a loop, and then d main is some kind of loop. Or this is dot text dot underscore d main. Oh. Those are probably different functions you can have, but I still want to look at it just to figure out what some of that is. LEA is address distance, or DST equals address. I'm trying to think of what that would be. It's the colon character. Oh, okay. So here's the label. So the label's 0, 55, and it pushes RBP, which I don't know what that would be even. Is that what I'm learning, kind of? There's some of these that are more descriptive than others, like move, for example, isn't very that descriptive. Destination is destination. Oh, DST is destination. Okay, got it. So DST is the address you're sending it to. So the current address for LEA is 0x0, I guess. Have dark mode. My eyes hurt with this flashbang. Settings. Breeze dark. No. No, there's no way to force it to dark mode, maybe? Push RBP is moving RBP into the stack, so you can move RSP to RBP without overriding the previous RBP value. Pop returns the stack value. Yeah. Yeah, I see that now. That makes sense. So that basically push moves RBP, and then RSP is able to be assigned there by move, and then at the end pop returns RBP. So after this whole loop, that's what it does. Very fascinating, and something that's way above my brain cells right now. Mainly because I don't know assembly. So then on LEA we have something going on with this, and those are also specified down here in the document in this reference. Registers. So RIP is an instruction pointer. Bro, if I have to touch assembly, I'm gonna fucking melt, bro. This ain't it. This is terrible. Terrible assembly, bro. Turns the latest stack value to the RBP register. Okay. I think I fried my brain cells today. I don't think we're gonna make my own kernel. I think I've decided to... I think I've changed my mind. I think I want to step down from such complex projects. I think I need to relax my brain for a bit. Bro, people who wrote this shit are fucking psychopaths. Like, honestly, I don't think it's that bad if you're writing your own code. But if you're reading somebody else's code and going, what is this? What the fuck does this do? This is pain. You need to write your own code and then read somebody else's code and then be like, oh shit, I know what this is. Some dude wrote Roller Coaster Tycoon 1. Was it written entirely in assembly too? Bro, this shit's insane. Like, holy shit. And, yeah, this is my brain dying from this. We're gonna try to avoid assembly as much as possible. In fact, we're gonna write the whole thing in D-lang because, I mean, even though it's like so long and I don't feel like half that shit's being used, I think we could just remove it from the compiler and then just assemble this as is. I'm pretty sure. So like what I think we can do, instead of trying to learn assembly to write like most of it in assembly, we can just take out the shit we don't need and just be like, alright, I know we don't need this because we're not using this shit. Throw it away. Straight up. I think that's what we can do. Or just trial and error until we have something that works. But it's like debloating Windows, I think. So that's what my plan is, you know, we have hello world.s, but if we wanted to write hello world.s and make it super easy, we just don't write any assembly and we just strip out all of the dumb shit we don't need. I think that's the way to go with that, because assembly is brain pain, and yeah. Anyway, I'd like to thank you all for watching. I'll see you all in the next one, and hopefully I won't... The bootloader itself needs to be written in assembly. God damn it! Oh, shit! Oh. This is actually good information, though. So the bootloader itself... So how would you even bootload anything? Like, I think we need to figure that out next time. This is above my level. Above my brain cells. I think I've stepped too deep. Like, this is like swimming into the deep end and not having any clue what you're doing. So we're gonna just cancel this project for the time being and save it for when I think I am more competent at programming after we learn assembly. At least we did something productive, though. And by something productive, it was not unproductive for me to see what D-lang looks like in assembly. That was one of my goals. Yes. It's just kind of, yeah. They do. Anyway, I want to thank you all for watching. I'll see you all next time. And hopefully we'll do something else. Maybe, like, try messing around with derelicts or some shit again. But I did actually get some of that shit to work, so see you all next time and goodbye.